Yeah, so good morning, everyone. And today we are meeting to discuss the project on exoplanets, right? Now, the job is very simple because I hope most of you all have attended the session which was done by Timothy Hamilton, right? So Timothy Hamilton did a very long, very well described session on how to analyze exoplanet data for Kepler, okay? So if I share the screen, I can show you. If you come on to our projects page, right? And this is the main projects page which we have. If you click on exoplanets, right? What I've done is I've directly linked it to a document. Okay. The document is the document given to us by Timothy Hamilton, which is on how to measure exoplanets with the transit method. Okay. Now, by transit method, you basically mean is you are getting a light curve, right? The exoplanet is coming in front of the what do you say, in front of the star, due to which the starlight gets diminished. Okay. And then what you do is they do something called folding. By folding, what happens is, this is also done in radio data for on many such data which you have, which is time variable data, right? That is, if you have the period, the time period of some data with which it varies, you fold it, right? Just think of it as a long strip of paper where you have these wiggles, right? But once you know the time period, you fold it and you overlay all the wiggles one on another, right? So all these points, right? All these points are from different dates, but they correspond to the same phases, right? So you have a certain phase of the revolution of that planet around the star, and therefore the phase is varying from 0 to 3. I hope you all can see my screen, right? You can see this Kepler folded light curve.
Yes,
Hello.
ma'am.
Yeah.
Yes, ma'am.
So this is a very standard procedure which is done for time varying data, for data where there's a variation in time, that you fold the data as per the time period, right? So you find out the time period and then you fold it. So like I said, each point on this data set which you're seeing is not of the same date, but it corresponds to the same phase, right? So think of a long strip of paper where you have wiggles. You may have points at different phases on different days, right? But you can actually overlay these data and get this folded light curve, right? Now, there have been many exoplanet missions. The major two ones were Kepler, which is over, and there's a new one which is called TESS. Okay. Now, what Timothy Hamilton did is he showed us how to do it with Kepler data. So, the project purpose, first of all, is to learn how to handle transit data from Kepler. And this whole document which he gave us, right, this has a very detailed, like here you can see this is the theoretical background. Okay, that is how using Kepler's third law he actually gets you the the parameters for this thing, that is a is the distance of the planet from the star, right? So tentatively, if we know the mass of the star, we know the period. That's all we need to find out the distance, right? So if we know this, we can find out the A value and the semi-major axis, right? This will give you the semi-major axis, this formula. And then he's also showed us how to measure the size of the planet, which is a very simple thing. You are seeing the dip, right? The dip, the decrease in flux, which you're getting from the star. So you have the flux total minus the transit flux divided by this. So you're getting a ratio of the areas of these two objects, because you know that this dip is coming because the planet came in front of the star, right? So here is my flux. This is my, and just see, this is the level at which you are doing a measurement. Let's say the flux of the star is 1, is a unit 1. Then when the transit takes place, you have a 0.99. So you're basically getting only a 1% difference in the flux of the star, right? Which is being measured by Kepler. But Kepler can measure it very well because it's a satellite, it's out of the atmosphere, and therefore it can measure this to such an accuracy, right? With a ground-based telescope, you won't be able to do this with this kind of an accuracy, right? So the other thing which he's done, showed us here, the theory formula, etc., is how do you actually get the size of the planet by taking the ratios, a function of the two fluxes, right? So using that, he's giving you the radius of the planet. as a function of the radius of the star and these parameters, right? These which you will get from your data. The other thing which he's done is how do you calculate the temperature of the planet, right? So this is directly taken from Stephen Boltzmann's law, F is equal to sigma T power 4. And then you have the area already, right? You have the luminosity. We already know the radius from the previous step. So we can find out the temperature, right? And then you can do the absorption, get the absorption coefficient, etc., using this formula, and hence get the equilibrium, this thing. What he's also given us, which I shared with you all on WhatsApp, was a target list. This is a good target list. There are 5 planets for which you need to find out all these parameters. That is the distance, the mass, the radius, the temperature, right? All these things. And here is the detailed method of how to do it. Another thing to note is that when he did it, he basically showed it to us with Excel. I would obviously prefer if you do it with TopCat. And the other thing is that, again, you can also write Jupyter notebooks to do this same thing instead of doing it with this method, right? So that is, once you finish this thing, you can get that also. Okay, he's also done this business of planet's mass from radial velocity. So from the radial velocity data, substituting in this formula, you can get the mass of the planet also, right? So this is about the thing. And here, once you get the mass, you have the radius. So you can get the density of the planet, right? And here you have a plot where he's given you typical mass radius diagrams for different planets, right? So this is where Venus and Earth lie, but Uranus, Neptune is here, Saturn, Jupiter, etc. So when you find your object, you can also plot your object on such a plot to see what kind of a planet are you talking about, right? These are rocky terrestrial planets, and these are, the gaseous planets. So the idea is you will use Kepler data to get all these parameters for your exoplanet. Like I said, further steps in this is you can do this with Jupyter notebooks, you can do it with TopCat, and then the more adventurous amongst you can and should try this out with test data, because test data is also similar transit data, but you will have to use your experience from this data to apply it for test data. Okay, so that is my description. And now I will, the ball is in your court. I'm going to stop the share. All of you all have permission to share your screens as well as to talk, right? And therefore, I request all of you all to, I want to stop the share. Yeah, so I hope I've stopped the share, right? So I've stopped the share, and I request all of you to show me your these things. There's no video coming. There's no video coming. Okay. So let us this thing. So I open it to everybody. Whoever wants to, put on this. Yeah. So I open it to everyone to start sharing what they want to share.
Ma'am, I had a small doubt. If you could kindly clarify. Ma'am, the thing is, like in order to plot graphs, I have been using MATLAB.
Okay.
Would that be okay if I
Absolutely. See, we have no rule book. You plot it using whatever software is comfortable for you. We have no issues about that. You can do whatever you want. No problem.
And okay, thank you, ma'am. Thank you.
Yeah. So who was that, Sargam? Who was that? Whose question was that?
Ma'am, Satyaki.
Okay. Now the others also can come up with what do they want to ask, and so let me hear a report from each of you. So Aishwarya, how's your work going? What have you done?
Yes, ma'am. I have downloaded all the data sets, and now I am currently working with 6B and 4B data.
Okay. So do you want to show us any plots or any values that you have?
No, ma'am. Actually, currently I'm not in my computer. That's why I can't share.
Okay. But then what you can try doing is that next time when you are
yes, ma'am. I will surely share that.
Yeah, because what I want, these sessions are basically small sessions where I would like to see what each of you are doing, right? So that at a personal level, I can check problems that you are facing or whoever else is facing, right? So I would like to know what are the problems different people.
Ma'am, we can do that in Top Cut also,
Yeah,
right?
yeah. That's what I'm saying. See, that's why we taught you all various tools. We taught you Topcat, we showed you Python, we showed you various other things. And there is no rule that you have to follow a certain software. Sometimes the software is more better tuned for certain things. And for example, in Python, there are many add-on packages which are already available, you know. So for example,
Yes,
if you go
ma'am.
on to Python, they may be of use to you so that you can use those packages, right? For it could be for curve fitting, right? If you're fitting it to some values, it could be for anything that could be useful. But otherwise, in principle, there's no hard and fast rule as to which software to use, right? So Sargam, how is life with you? What's on? Sargam. Sargam, can you hear me? Or let's take Satyajit. Satyajit. Okay. Okay. So,
And ma'am, I have one more question. Will
yeah.
you please share something about the presentation? We have to make a report on that, or
Yes. So the plan is that in the second half of February, rather the last 2 weekends of February, 20th, 21st, or 27th, 28th, there are 2 weekends in Feb. That's when individually we would like each of you to present what you did in the project, right? It can be a 10-minute, 5-10 minute presentation, right? But basically, we want to keep track of individually how far have we progressed. More than a test for you all, it's a test for us to know how, did we manage to make you all learn to do something, right? So, and then just to incentive for you guys, we've kept it that, okay, based on that, you'll get your certificate. But that's not an important thing. It's more important for you to, to show us that you understood how to do it, right? And so that's it. So that'll be in the end, towards the end of Feb, right? So you have a month. You have a month just now to this thing, and it's up to you how deep you go, right? So when you show
yes,
it to
ma'am.
us in February, it depends whether you stopped with Kepler or you went up to tests or you went beyond tests or what did you do. So we would also like to see what is the depth to which you people work, right? That's also interesting for us. Yeah.
And this thing can continue beyond February too. But end of February, we'll see how much people have, how far they have reached.
Yeah.
And with your mentors, you may continue for the whole year or for
Yeah.
many years.
Yeah. So,
Yeah.
yeah. So, like Sir has mentioned, this particular project, Astronomy from Archival Data, was only a 6-month project. So, we are winding it up in Feb. Okay. But immediately, we already have a new project, which is Astro Sprint, which is a continuation of this, which will continue for the whole year. So, we'll be continuing on the same lines with Astro Sprint. We obviously don't want to repeat what we did here. We want to add in some more things. So, Astro Sprint will anyway continue. So, don't think of this as the end of the thing. Hopefully this will be the beginning, right? So 1 minute, who is telling me that he can't show? Who has this doubt? Sargam, you said your, whose microphone is not working? Your microphone is not working. Okay, don't worry too much about the report and all that. You just have to give it in the form of some kind of a document, right? And you want to show your graph, you can show your graph. All of you all have permissions to share the screen. So Sargam, if you want to show your graph, you have permission to share the screen. You can share it. Yeah. Okay, very good. It's a sad thing that you can't talk. We can't hear you. So he's saying his mic is not working. So you type on your chat screen, whatever. Have you got the parameters for this planet? Have you managed to get the parameters for this planet? Hello? Sargam. So this is a good plot, Sargam, but I need to get all the values of the parameters. I need to see what are the values you got for your parameters. Okay. Tanushri just came in. You can later on see the recording. But tell us, Tanushri, have you done anything? Have you tried out your hand with some data? Tanushri, unmute yourself.
Hello, ma.
Yeah, hello, hi. So
Yeah,
have you tried doing something?
ma'am. No, I've not started actually with the exoplanets, but I was also a part of Magnetas group, so I was actually doing that,
Okay.
and I'm thinking of doing this week, so I will let you know.
Okay, no problem. So you can have a look at the video. I mean, in the beginning of the video, in the first 5-10 minutes, I've just described the project. So you can have a look at that. And
Yes,
by the next meeting, you can show us something, right?
yes.
So
Actually, I
by,
doing
yeah,
it when about the exoplanets thing when Tim Hamilton had done. I had tried actually everything. I'd found out the parameters and all.
very good.
Yeah. So I'll show it in the next meeting.
Okay, no problem. And like I mentioned, the steps ahead are number one, try doing the same thing with a Jupyter notebook, right? And
Yes, ma'am.
number two, try doing it with test data.
Okay.
Okay, so I want you guys to go as much ahead as you all can, right?
Yes, sure.
So push yourself and see if you can, how much you can do it. So like when you all will be presenting on February, we see this is the basic project we are telling you to do, but you are obviously most welcome to go ahead with it, you know, to go more beyond with it. So I would encourage you all to think of how to build it up further also, other than the ideas that I'm giving you, right? So you're welcome to do that. Come on, Satyajit. Satyajit, what have you done? Satyajit? Satyajit, are you there? You can use the chat window if you have a mic problem. So please, next time, all of you all sit on a device where you can even share your plots, etc., right? Because we can all see each other's plots. Satyajit, do you have anything? Satyaki, I think you already showed us, right, Satyaki?
Ma'am, actually, I have downloaded the data. I had a doubt regarding where to plot it, so I'll
Okay.
start.
Okay, no problem. So does anybody want to show us anything or share anything? Or I think maybe you're not very clear as to what these sessions will be. So like I told you all earlier, what we're going to do in these Zoom sessions is, since it's a smaller group, each of you all will individually share what you all got, right? What were the plots you all got? What were the values you all got? What were the specific problems each of you all have faced, okay? Because now we'll do it more on a personal basis, so we can see specifically who has what problem, right? So if you want, we can end up the meeting now, because not many, I think none of you all have anything else to show. But on the WhatsApp, there's a link which is there. You can go and share it with all of you. What were the results you got? Yeah. So is there anything people want to say? Hello. Hello, everyone. Is there anything else you all want to share? Or should we stop now? Then we can stop and have a meeting again soon. You all message me on WhatsApp and we'll fix up a meeting when you all are all better prepared. Right?
Yeah, see,
Yeah.
it's important that you all try to do something. And when you have issues, you have problems with getting data or plotting or analyzing, that's what we should be discussing here. Okay.
Fine. Is that fine
So
with
you
everyone?
have
Yeah.
to try. You have to now get down to doing it.
Yeah.
And the issues which come are to be discussed here. Okay. And whenever you require, you can ask for a
Yeah.
session.
So if you have a short question, you can put it up on the WhatsApp chat. And not only me, even your other friends who are involved in the same project, they may answer your questions, right? So if there are smaller questions, you can put it up on the chat window. And otherwise, we'll have the next Zoom session where we can see individual plots. Okay? But otherwise, you are on your own and you got to work on your own, right? Is that fine with everyone?
Yes,
Hello?
ma'am,
Yes,
that's
ma'am.
fine.
Yes, ma'am.
Yeah? Okay. So we'll meet again because I think now nobody else has anything else to show. So I'll stop the meeting, but let's be prepared for the next meeting where we can share each other's plots as well as whatever problems or issues each one faces, right? So that it's more at an individual level. See, now it's the phase where it's more you all have to do and you all have to do more talking than us, right? So see you. We'll meet again. Let's plan a meeting next. Okay? Is that fine? Bye.
Yes, ma'am. Yes, ma'am.
Yes,
Yeah.
ma'am.
Okay then. Yeah. Bye. Bye. Bye.